Hey everybody, today we are going to be talking a little bit about molecular formulas. And I always like to introduce this lesson with a little bit of kind of real world example of how we could use this. And not only that, but also I'm a big true crime fanatic and I wanted to introduce this using a murder mystery. So here we go. In the early hours of Wednesday, November 11th, a body was discovered at the world-renowned Bronx High School of Science. The janitor who discovered the body described the discovery as both a shock and a horror. "It just isn't what you would expect to see," exclaimed the janitor, whom asked to remain nameless as to protect his identity. "You walk into a classroom after some students leave and expect to see perhaps some discarded papers, maybe some water bottles, not a dead body." The body, which was discovered in the science wing of the school, was that of Harry Berman, age 32, originally of Albany, New York. Mr. Berman, who had never been to the Bronx High School of Science, was in the school to check the gas valves in all of the classrooms. At this time, the only possible suspects in the school are the teachers in the science department. Only 4 teachers remained in the school past 5 p.m. on Tuesday evening. Investigators have been in and out of the school for the past few evenings to try to solve the mysterious death of Mr. Harry Berman. Initial investigators say they found several signs around the death site that suggest foul play. 4 possible causes of his untimely death have been suggested. It is your goal as chemistry specialists to help in this important investigation. Who killed Harry? The possible suspects are Mr. Mulick, Miss Thomas, Miss Daly, or Mrs. Whedon. You and your classmates are going to receive the 4 possible causes of death and will be responsible for determining which chemistry teacher was responsible. Best of luck. All right, so what we are going to do is I'm going to first introduce you to the molecular formula, and then we're going to come back and look at one of these examples together. And then in class, I'm going to give you guys time to solve the other 3 and then research those and try to figure out who it was that killed Mr. Harry Berman. So let's go ahead and first talk a little bit about the molecular formula. Now, we've already discussed the empirical formula, which is not particularly helpful in solving this murder mystery. Remember that the empirical formula, which I'll abbreviate with EF, is the most simple ratio of atoms in a chemical formula. So while it tells us information about the chemical formula, it doesn't tell us exactly what that formula is for. And therefore, because of that, it's not particularly helpful to us. However, a molecular formula, which I'm going to abbreviate with MF, molecular formula, okay, is the chemical formula which gives the exact number of atoms, okay, of each element in a molecule, okay, or in the formula. And so molecular formulas are going to be a lot more important to us because they're going to tell us the exact ratio of atoms, or the exact number of atoms, in the formula. And so we did this a little bit in class, but if we're given, let's say, an empirical formula, and I want you to determine the molecular formula from that empirical formula, right, then you could probably be able to give me some examples. So let's say that I was given the empirical formula of C2H3. What are some possible molecular formulas that are, possibilities based on this empirical formula? Now, again, remember that the empirical formula is the lowest ratio of atoms. So if we're looking for molecular formulas, they can be any multiple of this value. So, for example, C4H6 could be an example, or C5, maybe I don't want to do C5 off the top of my head, but let's do let me erase that. Let's do C8, H12, right? So how do I get to these? Well, if I'm multiplying this by 4, then I would have to multiply this by 4 to get to this value. C16, H24, C6, H9. These are all examples of possible molecular formulas. I also want to take a moment to point out to you that in addition to these values, C2H3 is a possible molecular formula as well. So just because something is the lowest whole number ratio doesn't mean that it is not possible that it is not the molecular formula as well. And that's kind of a roundabout way of saying something like, for example, H2O, which is the lowest whole number ratio of atoms that are possible. That is not only an empirical formula, but it's also a molecular formula. Okay, so they can be the same. They can be the same. All right. So how do we solve for the molecular formula? So let's go ahead and take a look at an example problem. So given this example, we'll say a substance was analyzed and found to have a molecular or molar mass. Okay, so I'm going to use interchangeably molecular mass, okay, of 88 grams per mole. Okay, and it was found to have the empirical formula of C2OH4. I want to know from this information, what is the molecular formula of my substance? So it's really just a quick 3-step process to figure out the molecular formula from the empirical formula. So first step number 1, okay, is going to be to calculate the gram formula mass of the empirical formula, okay? Because the empirical formula, again, is the lowest whole number ratio. So if we have that lowest whole number ratio, we should be able to see how many times it essentially fits into this given molecular mass, and we can figure out how many times we need to multiply our empirical formula. So we need to calculate the empirical formula of the gram formula mass of the empirical formula. So we have carbon, hydrogen, and oxygen. Carbon, there are 2, hydrogen, there are 4, and oxygen, there is 1. Carbon weighs 12.01 approximately, H weighs 1.01 approximately, and O weighs 16 approximately. And this is going to give us a gram formula mass of right around 44 grams per mole. Okay, I'm going to round it to the nearest whole number since my molecular mass that's provided is to the nearest whole number. Okay, from there, we can move on to step 2, okay, which is going to be to divide the molecular mass or the molar mass that's given, okay, by the empirical formula GFM. And so we get 88 grams per mole divided by 44 grams per mole. And this tells us that we have 2 times the number of atoms that our empirical formula has, right? It gives us that numerical value of 2. But again, think about it. We're looking for another, a set of numbers that fits within that ratio. And so if we have a 44 grams per mole mass, but our substance actually has 88 grams per mole, we know that really we have double the number of atoms that we had initially thought. And so the last step to kind of put that into an actual step, we're going to multiply the empirical formula by the number from step 2. Okay, and so for this problem, okay, let's go ahead. I'm just going to give myself a little more space here. Okay, our empirical formula was C2OH4. I'm going to multiply by 2 for each of these, giving me C4O2H8 as my molecular formula. Okay, so pretty straightforward, nice and easy to solve for the molecular formula. Now, in class tomorrow, like I just mentioned, you guys are going to be solving the mysterious murder of Mr. Harry Berman. And so for that mystery murder, let me just go ahead and pull up an example for you to take a look at. Okay, so here we can see, okay, we have an unlabeled drug bottle, and I'm going to go ahead and just do this so that I have on both screens so I can write for you. So an unlabeled drug bottle in the classroom where Mr. Berman was found. Okay, there was a 5.3299 gram sample, okay, that was analyzed and found to contain 3.4612 grams of carbon, 0.2398 grams of hydrogen, 1.0852 grams of oxygen and 0.5436 grams of sulfur. Okay, and it says the molar mass of the compound was found to be, so the molar mass was found to be 314.38 grams per mole. It may be a drug prescribed for nodules on the vocal cords. Did you know that Miss Daly was an excellent singer? Coincidentally, Miss Daly was prescribed this exact medication not long after she graduated high school when her nodules became unbearable. Overdose of the drug can be extremely dangerous, and it doesn't help that the drug looks like candy. Did Miss Daly trick Mr. Berman into believing the drug was candy in order to slip him a fatal overdose? So the question is, how do I go from this information that I have to the molecular formula? Well, what you're going to notice is that I was not provided an empirical formula here. So the first thing that I would have to do is go ahead and solve for the empirical formula. So step one is going to be to find the empirical formula. Okay. And so in order to do that, again, we're going to have to typically follow our Pohm percent to mass to moles, divide by small, multiply to whole. But we're already given starting mass values for all of these different substances. And so what we want to do is we want to go ahead and use those to solve for our values. So 3.4612 grams, again, of carbon is equal to X moles of carbon. We're going to divide by that gram formula mass, 12.01 grams per mole. Okay, we have 0.2398 grams of hydrogen. I want to know how many moles of hydrogen that is, and we're going to divide by 1.01 grams per mole. Okay, we then have 1.0852 grams of oxygen, and I want to know how many moles of oxygen that is, so I have to divide that by the gram formula mass of oxygen. And lastly, I have 0.5436 grams of sulfur, and I want to go ahead and know how many moles of sulfur that is, and I have to divide that by the gram formula mass of sulfur, which is 32.07 grams per mole.